Okay, guys, today we're going to start Chapter 7, Section 7, Scale Drawings. And we are going to go over some definitions. A scale drawing is a two-dimensional drawing that accurately represents an object. That could be like if you're getting a house built, and before they build the house, they make what they call a blueprint, and that's like the scale drawing. It shows you where the layout of all the rooms and everything's going to be. So if you want to make any changes before the house is actually built, you use the scale drawing to do that. And then the scale gives you the ratio of the dimensions in the drawing to the dimensions in the real object. So if 2 inches take up where the shower is going to be on the scale drawing, there is some sort of a ratio or proportion set up to where how big that actual shower is going to take up in the actual house. Okay, so to find the scale, you take the dimensions in the drawing in the numerator, and the dimensions of the actual object in real life are going to go in the denominator. Okay, so all dimensions are reduced or enlarged using the same scale. Scales can be used with same units or different units. So 1 to 20 means 1 unit on the drawing is 20 units on the object. That means if it doesn't have any units, that means that is in the same units, okay? And 1 centimeter, 1 meter, that means 1 centimeter on the drawing is 1 meter on the object. So if you have different units, you need to write both the different units in. And 1/4 inch equals 1 foot, that means 1/4 inch on the drawing is equal to 1 foot on the actual object. All right, so reading in math, the scale A:B is read A2B. So when you see the colon, the 2 dots, you put the word 2 in there. For example, the scale 1 centimeter, 3 feet is read 1 centimeter to 3 feet. So the colon is replaced with the word 2. Okay, so for example, A here, the length of an object on a scale drawing is 2 centimeters. Its actual length is 8 centimeters. The scale is 1 centimeter to something. What is the scale? Okay, so we're going to set it up, and we're going to have 2 centimeters over 8 meters. And all we're going to do is we're going to reduce those, okay? And we are going to reduce them. So we end up with 2 divided by 2 is 1 centimeter, and 8 divided by 2 is 4 meters. So we just divided each of our terms by 2. Okay, so we end up with 1 centimeter over 4 meters. Okay, so 1 centimeter to 4 meters. I'm going to fill that in right here. So what is the scale? The scale is 1 centimeter to 4 meters. Okay? So the next one, example B, the length of an object on a scale drawing is 1.5 inches. The scale is 1 inch to 6 feet. What is the actual length of the object? So since we know they're proportional, we're just going to use these values to set up a proportion. So what we had just seen, if we scroll back up, it says when you're doing the scale, you want the dimensions of the drawing over the dimensions of the object. So the drawing I usually call the model, because sometimes it's a drawing, sometimes it could be a model airplane as opposed to a real airplane, a model car as opposed to a real car. So I usually use the words model over actual, and then the actual is the car, the house, the model, the airplane, whatever the item may be. So we use the scale first that they give us, which is right here, 1 inch to 6 feet. So I'm going to put 1 inch over 6 feet. And now everything for my model is in inches, and everything for my actual is in feet. Okay, so anytime I have a unit in inches, it's going to go in my numerator, and anytime I have a unit in feet, it's going to go in my denominator. Okay, so it says the length of an object on a scale drawing is 1.5 inches, so that 1.5 is going to stay in the numerator where inches is. And then what is the actual length? This is going to be a variable. That's what we're trying to find out. Okay? So we're going to have to do some cross multiplication here. So 1 times x is 1x, or just x, and 6 times 1.5 is 9. So we get 1x equals 9, or just x equals 9. Excuse me. So 9 foot is your answer. Okay, and if you wanted to know the scale factor again, this is the scale, or the scale factor, 1 inch to 6 feet. Okay, a scale drawing is smaller than the actual object is called a reduction. A scale drawing that can be larger than the actual object is called an enlargement. So, perfect example. You have a picture that comes, 4 by 6, a regular size picture. You can get that enlarged made bigger into a poster size or an 8 by 10, that's an enlargement of the original picture, looks exactly the same, just a bigger size. You can also get that picture made smaller, maybe into a wallet size picture, and so that would be a reduction. Still looks like the picture, everything is still in proportion to each other, all the people look the same, it's just a smaller version of the original. Okay, so letter A. Under a 10,000 to 1 microscope view, a fiber appears to have a length of 3 millimeters. What is the actual length? Okay, so we're going to start out just the same, model over actual. And on these, we're going to set them up kind of like we did the hard ones on our last quiz. Okay, so I'm going to have my, go to our scale factor, which is right here, 10,000 to 1. So we're going to have 10,000 on the model is going to be equivalent to 1 on the actual. Okay, if it appears to be a length of 3 millimeters, so that's the model, what is it actually? It would be x. Okay? So again, we need to cross multiply and divide. So 3 times 1 is 3. 10,000 times x is 10,000x. Okay, we undo multiplication with division, so we divide both sides by 10,000. That's a comma there, sorry, it won't come on. So we need to do 3 divided into 10,000. So you can either move your decimal point, or you can actually do the division, and you're going to end up with, remember we need to move the decimal point however many zeros there are, and you're going to end up with 0.0003, and that would be our unit millimeters. Okay, or tenths, hundredths, thousandths, 10,000ths, 3 10,000ths of a millimeter. Okay, a drawing that uses the scale 1/4 inch equals 1 foot is said to have 1/4 inch scale. Similarly, a drawing that uses the scale 1/2 inch to 1 foot is said to have 1/2 inch scale. Okay, so you're going to want to remember that for the next couple that we're going to do. So I'm just going to put a big circle around that. So for letter B, if a wall in a 1/4 inch scale drawing is 5 inches tall, how tall is the actual wall? Okay, so again, we're going to do model over actual. So we have a quarter, they just told us, remember 1/4 inch scale, I'm looking up here, 1/4 inch scale is 1/4 inch to 1 foot. So 1/4 inch is going to go in my numerator, and 1 foot will go in our denominator. And then since the scale or the model is 5 inches, I need to put 5 inches up on the numerator, and the actual we don't know, so we just put a variable. You can pick whatever variable you want. Again, we're going to have to cross multiply and divide. So 1/4 times x is 1/4 x equals 5 times 1 is 5. Okay, we need to undo multiplication with division, but we don't divide fractions. We multiply by the reciprocal, which is 4 over 1. Okay, so we're going to end up with the 4s and the 1/4 canceling out. So we get x equals 5 times 4 is 20. And my unit for my denominator is feet. So x equals 20 feet. Okay, have a good afternoon, and I will see you guys tomorrow.